fourth webinar. That's the voice of authority, the WIMBA voice. We'll hear it one more time in about 60 minutes from now. Again, thank you very much, everyone, for joining us in what is an evening teleconference here in Toronto. For some of you, late afternoon on the West Coast. And in a few minutes, we'll actually ask where all of you are from. I just scanned the list of people who are already on the call. We're expecting many more to join you. But many of you, I recognize names of people with considerable experience in energy and climate change education who've signed up. So I know we're going to have a great question session in a few minutes. Well, in fact, let me just jump to that point. Pat Higby, who I'll introduce in a few moments, will give us a 25 to 30-minute presentation, in the midst of which will be some questions of you as the audience to get some feedback and help Pat, make sure that the presentation is of maximum value to those of you on the call. After Pat's presentation, we'll throw it open to everyone to ask questions, and you'll see an opportunity on the screen in a special slide for you to submit those questions, and then I'll relay them to Pat. But in the meantime, many of you have been, I recognize many of the names of people who are on this call already as people who've been in our previous webinars. We had 2 earlier this week, 1 last week. And you already know what I need to tell other people here, which is that in the middle of the presentation, or anytime you wish, just as you've already seen, there's a chat box in the bottom left-hand corner. And you can type a message anytime into the blank screen, as several people have done already, and make a comment or ask a question. And you'll quickly see if our past experience of the other Ask Unites is any indication, there'll be a pretty good conversation going on the left-hand side, and people will be helping address some points, or if they didn't quite hear what Pat had to say, or they wanted a little bit clarification, and I'll be following that too, so that if there's anything that's important that I need to relay to Pat, who of course won't be able to pay attention to the chat box during her presentation. Just a quick note of introduction.
This is Pat Higby. We seem to have lost Tim Grant. Can you hear me?
I can hear you, Pat. Are other people not hearing me?
They've lost the sound.
Now you can be heard here.
Okay, I think what it is sometimes I forget to hold down the talk button, and I will do better. And of course, I'm not going to talk for very long anyways, but thank you for alerting me. I must have let go of the button. Okay, so I was just going to say that for those who aren't familiar, and I would encourage you to have a look at, if you're not familiar with Green Teacher, please do have a look after this webinar at greenteacher.com. You can view a sample issue of our quarterly magazine. You'll soon see that we've published 6 books, and I'm going to ask Pat right now, can you advance the slide, please? Perfect. Okay. And again, can you advance to the next slide? Great. Okay. So that's enough about Green Teacher for now. But I would encourage you, if you're not a subscriber, we are an unprofitable nonprofit organization, and we are dependent on subscription and book sales. So if you're not a subscriber, do consider taking out a subscription, getting your school or your organization, your nonprofit to subscribe, or pick up one of our books that can help support the work that you're already doing in energy and environmental education. Okay, so I've already told you what we're going to do tonight. I didn't say one other thing that we've done the last couple of nights, which is that after we finish the question period and the hour is up, at the end of that there'll be a short survey, which I would invite everyone to stay, and it takes a maximum of 2 minutes to fill out. And if you do, you'll be eligible for one of 2 free 1-year digital subscriptions to Green Teacher. But in addition, what we found the last couple of nights is a number of people hung around after that, and what we did was we unmuted the participants and gave an opportunity for people to ask live questions rather than just funneling them through me. So I hope that those of you who want to stay and ask, if we haven't had a chance to ask your own question, or you think of another one after we're filling out the survey, then by all means do stay around, and hopefully Pat will have a few extra minutes and we can ask those questions. Okay, well, without further ado, here, let me introduce our very special presenter this evening. Those of you who've been waiting for this teleconference for a good 20 minutes will remember me saying a moment ago that Pat works at the University of Northern Iowa's Center for Energy and Environmental Education. She's been working there for 10 years, and I've only recently come to know Pat, but she is a person who, but her center I've been aware of for a good, almost as long as we've been working on Green Teacher magazine. They've been doing amazing energy education work. They're really one of the centers on this continent, and of course now are beginning to address the topic of climate change as well. Pat began her career as a science, math, physics teacher, then discovered that non-formal education in science museums was more challenging because one's audience can leave if your presentations are boring, unlike the classroom. She and her husband have 2 grown children, 2 grandsons, and as you've seen in the picture of her in the bottom right hand of the screen, a dog that likes to go to work with her. She enjoys bicycling, gardening, and spending time with her family. Please join me in a warm welcome for Pat. Pat, take it away.
Thank you very much, Tim. And now that you've had a chance to introduce me and where I'm from, let's go to that question slide so that we can find out where our participants are from, and we'll ask them to please fill that out. And Tim, if you'll just let me know when you want me to move forward, I will do that.
I think you can probably, people have been able to type in by now, Pat, so I think carry on.
All right, thank you. I've locked my talk on, so we're ready to go. And our first question really relates to why do energy education anyway? The other question that we have is how do we do education? Well, in the United States, we emphasize an inquiry approach, and we do this primarily because it's often related to science curriculum. And in Iowa, that inquiry approach follows the 5 E's method. So you should see engagement, exploration, explanation, chances to expand, and evaluate, all as part of this presentation, because we do try to walk the walk as well as talk the talk. I'm not always perfect on this, but we're going to try. So let's get started. Before we start with some evaluation, we just said how important it is. Could you please respond to these questions below and then click Submit? First, how comfortable are you about teaching energy-related topics? Are you uncomfortable, somewhat uncomfortable, or are you fine with it? Are you comfortable? Our second question, what would you identify as the most important reason for your answer to the previous question? Is it because of your personal level of interest in the topic of energy? Is it because of your professional preparation to teach about energy? Whether it's good or a little bit lacking, whichever, what was your professional preparation? What about the availability of tools and materials to teach about energy? Is that what's limiting or enabling you to do this? And last of all, is it how well that energy fits into your local curriculum requirements? So if you will, please click those buttons and then hit Submit. I'll just give you a little time to do that.
And Pat, while you're doing that, I can report that we have people from all across Canada and the United States, literally from the east and the west coast, and points in between on this call. So, and from Alaska to Florida and New Brunswick to California.
Oh, that is fantastic, Tim. Thank you so much. All right, well, let's move on. Okay, why do we need energy education? When I ask this question, whether of K-12 students, college students, or adults, these are the usual answers. They say we need energy education because we're running out of oil, because of national security issues based on our oil sources, and I can assure you that we're not worried about our Canadian oil coming from north of the border, it's other areas. They talk about the rising cost of energy, the fact that coal is too dirty and dangerous, and the slide here, the picture is our Chilean miners that were rescued. Unfortunately, we can't seem to rescue all of our poor coal miners, as we found to our dismay here in the U.S. Usually kind of the last thing I hear about here in conservative Iowa is climate change issues. And so I just have to ask, what's so bad about climate change? I'm here in Iowa, and it's snowing out there, and if it gets warmer, my roses won't freeze. But for students, their most frequent answer about what's so bad about climate change is always polar bears are drowning. For some reason, that is their greatest motivation. They are just riveted by the idea that we're going to lose our polar bears. But my question is, what about increased precipitation and flooding? That has been an issue in Iowa. So here's a question for all of you again. Have you or someone you have personally known been affected by a severe weather event, such as flooding, drought, or high winds during the past 3 to 5 years? And if yes, what was the location of the event? So please go ahead and answer those questions. And Tim, I'm going to unlock, and hopefully you've got some answers about the last responses.
Well, yes, the first one is that of those on the call, the 27 that responded, 15 are somewhat uncomfortable about teaching about energy, and 9 are comfortable. That's the major finding from that poll, and I haven't got to the other poll yet.
Okay, fantastic. Well, that sounds really good. I'm pleased because I was expecting to have, but then we're singing to the choir here, or preaching to the choir, excuse me. So I am very pleased that so many of you are comfortable about teaching about energy. Well, let's move on to an activity. Let's do a little exploration here. So we're going to work with what we call the Earth-Water cycle. And this activity is going to be simple, yet I have found it to be very effective for illustrating how a warmer Earth changes our water cycle. And since the water cycle is taught in every K-12 school, why not take the opportunity to expand our students' learning to include a motivation for changes in energy production and use? And you will note that I did misspell the second Earth here. That's based on the recent book by Bill McKibben. He's the 350.org founder, and he says we're going to be living in a different Earth, so we should spell it differently as well. Okay, so here's what I want you to do. Fill 1 cup, styrofoam is nice, about 2/3 full of warm water. Now this is water you could bathe a baby in. It's warm, but not too hot. Put the cup in a quart Ziploc bag and seal it. Repeat these steps with a cup of really hot water, or you can even use coffee fresh from the pot. Do not put your finger in this liquid. It is hot and dangerous. And then what we're going to do is observe and note any differences between these two systems, because what we're doing are showing the water cycle in 2 little bags here, and we'll be watching them as we go through. And I'm going to talk a while so that we give this whole operation a chance to start to do its little cooking thing. At this point, I often have participants draw the water cycle. It allows me to measure their prior knowledge, and then I can review any points that they may have forgotten. You'd be surprised how many forget to include snow as a precipitation. It seems like most of our diagrams in the state's textbooks anyway, always show rain but seldom show snow, and therefore our students forget about snow as well. But I can assure you, when it's too cold to rain, it snows, and I've got snow outside the window right now. So now for a question, is the Earth warmer now? What was the hottest decade on record? And you don't have to answer this for Tim, because I'm going to share that with you right now. It's an easy answer. The hottest decade was the last decade. January of 2000 through December 2009, hottest decade on record. And you should hopefully be able to see the changes in temperature against that backdrop of the Earth on the slide here. It just so happens that 2010 and 2005 are tied for the hottest, while 1998, 2002, 2003, 2006, and 2007, those are all tied for the second warmest. So you can see, yeah, we're warmer now. We're absolutely warmer. But why is the Earth warmer? What else has risen besides temperature? And the answer to that is pretty obvious, and as I said, we're kind of preaching to the crowd, to the choir here, so I hope you don't mind that I'm probably going to be telling you things you already know, but I did want you to see how I go about this presentation with students here in, as I said, conservative Iowa. So we can see that carbon dioxide in the atmosphere has really been rising. Does an increase in carbon dioxide lead to warmer temperatures? Well, does an extra blanket keep you warmer at night? We know for sure this is a greenhouse gas, and the greenhouse effect is that if you increase layers of glass on a greenhouse, or if you increase the gases, it is, in fact, going to increase the temperature. Now, this is a really good place to discuss the effect of photosynthesis and bacterial decay on the annual cycle. And you can see that little annual cycle there. I'm going to blow that up for you. And here's how I try to tease this answer out of my students. You know, trying to use the inquiry approach, we're not supposed to lecture to people, so I feel a little uncomfortable doing this presentation. But with enough of the right questions, I can get the students to understand this, and then I use pictures like this to explain as we go along, that in the winter, we can watch as the amount of carbon dioxide gradually increases until it comes up to a peak in about April and May. And at that time, here's my personal carbon bank. I can hold it in one hand. I've got packages of seeds. And so I get those into the ground, and then all summer long, those plants are so busy taking carbon dioxide out of the air and taking water out of the soil and taking energy, of course, from the sun, and converting that into glucose and oxygen. And that glucose is what they're building their plant matter with. So that by the end of the summer, by the end of the fall, we have just loads and loads of plant material. Look at the difference between the leaves on the trees in that early spring photo compared to the late summer. We have tree leaves, we have vegetables. My carbon bank, I have to have a couple of pickup trucks to hold all the carbon that I have been harvesting from the atmosphere. But then, what happens over the winter? Well, taking a closer look at that center picture with the plastic greenhouse there, that bare soil is the key. Inside the soil, we have lots and lots of organisms. We have bacteria in there that all winter long are busy breaking down that material, the plant material, and in the process, releasing the carbon dioxide back into the atmosphere. And so there we go. That's the explanation for that roller coaster ride. So now students have a little bit of an understanding of photosynthesis. And what I want them to do is to see the carbon cycle. I don't ask them to draw this because it's pretty complex. And so instead what I do is I give them carbon cycle diagrams that I've pulled off from the internet, and then they use their diagrams to give me the numbers for these annual cycles. And then I just fill them into a blank diagram like the one that I'm showing here. And so let's kind of go a little bit further here. These are some examples of some different carbon cycles that I have pulled from the internet. You'll want to have some that are fairly simple because there are some that are more complex than this, because you want the students to be able to find their answers fairly easily there. And so let me go to one more. This is a pretty nice one too. And in this, students can see the balance in land and ocean carbon cycles. If you look over on the right-hand side, you can see that it's between 100 and 115, and the units here are billions of tons of carbon, or they're called gigatons, and that it is almost in balance. There's a little bit of imbalance here because the ocean has been a sponge. It's been soaking up some carbon for us. But pretty basically, it's almost balanced. And we've already talked about photosynthesis. But for the ocean carbon cycle, the best example I can give is a bottle of soda pop. When you open up that bottle of soda pop, it goes gives you a little bit of a pop sound. It's been under pressure, and when you open it, it releases gas. The gas it releases is carbon dioxide. And the ocean is doing that too. As pressures move across high pressure and low pressure regions, it's constantly releasing or absorbing carbon dioxide. And it also releases or absorbs carbon dioxide based on its temperature. So just as your soda pop and beer would go flat and lose the gas as it gets warm, the ocean, as it's getting warmer, is releasing more carbon dioxide too. So that's always kind of fun to try to have the students see that connection. We've talked about photosynthesis. The interesting thing there is that it's 100 to 120 billion tons that is absorbed from the atmosphere. And then the part that's released back again is in two arrows, one to show plant respiration, because plants do respire at night. The other is by the decay, and that's the soil decay. But when you add those two smaller arrows up, you see that you've got a balance on the land too. The thing that's not balanced here is our fossil fuel burning and, of course, our land use, our deforestation efforts. But look at those numbers. And I apologize if you can't see them very clearly. Our fossil fuel burning is about 5.3. Our land use is from about 0.5 to 2.6. Those don't seem like very big numbers when you compare them to the approximately 100 gigatons that we have in the other parts of this cycle. But the clue here, the thing you really want to have the kids tease out there, is that this is an annual cycle. And so the question that I ask next is, well, how long have humans been burning fossil fuels? How long have we been changing our land use? And after a little bit of coaxing and talking about Civil War days and what did we burn for energy in the Civil War, and going back even further to the start of the Industrial Revolution, they'll usually agree on about 200. And then, because we like to do easy math, I let them decide on a number that they feel comfortable with as an annual number over those 200 years. And often they choose 5. And so 1,000 billion tons does become significant. And now I think they have a much better understanding of why that first graph showing CO2 rise was going up so fast. Well, I've been talking long enough. I want you all to check your cups now. Can you see that more heat allows more evaporation and thus more condensation. I sure hope you've got cups in front of you, but if you don't, a really, really close look at these two, at the photo of the warm and the hot cup is pretty neat. The water droplets that form in the bag with the hot cup are significantly larger than the ones in the warm cup. And it's just so neat because kids can easily see that as being, wow, those must be really big thunderstorms that we get with a hotter earth compared to the smaller storms that we'd have with the warm earth. But we don't yet see the connection to flooding. So I'm going to ask you to very, very carefully remove your cups from the bags and then squeegee down. Oh, and I see somebody wants me to make these pictures bigger, but I'm sorry, I'm not real sure I can do that. But if you'll squeegee the water down into the corner of your bags, you'll be able to really see a significant difference in the amount of water in these two systems. And I think it's just pretty obvious why we've had such significant flooding. Here in Iowa, we've had it in 2008, right here in my hometown. We were busy putting sandbags on the levees. More recently, Pakistan and Australia have really been hit as well. But here's something else to consider. What you can't see is important too. The same amount of energy that was absorbed during evaporation is released during condensation. And in the atmosphere, this can result in very strong winds. Again, I've got a local example. Just 20 miles west of where I'm sitting now, we had the biggest tornado you can have at Parkersburg, Iowa. Fortunately, it went a little bit north as it came my way, and so it missed our community. But it just devastated Parkersburg, Iowa. Another place where you're going to see really strong winds is down with the hurricane season. And last year was just one hurricane after another. It was like a freight train. At one point I was watching the news. There were 4 hurricanes on the radar at the same time. Here I managed to find a picture that caught 3 of them. In the States we were lucky, but Mexico got hit, and it was just amazing. And at this point I'm going to ask you to think about 2 numbers, 7 and 8. 78 degrees, and we're talking Fahrenheit here, 78 degrees is how warm the water needs to be in order to have a hurricane. If it's not that warm, you don't get enough energy to have one. But reverse those numbers. 87 degrees was the temperature of the water when Hurricane Katrina formed. 87 degrees. It was almost too warm to go swimming comfortably. Okay, but back to the question of how to do energy education. There was a California study, and I've given the link here, of the best energy education practices for K-12, and they identified these needs. I think of it as a 3-legged stool. If you don't have one of the legs, it's just not going to work. For one thing, you need to educate teachers. You have to have professional development. Those teachers are not going to teach a topic until they feel comfortable with it themselves. Second, you need to provide teachers with equipment to allow for inquiry. How can you teach about photovoltaic cells if the kids don't have one to experiment with? They need equipment, and quite often our schools can't afford it. The third thing you need is time. And the way you get time to get into the classroom with this is to correlate your energy education with the required curriculum. In Iowa, we call it the Iowa Core. And so if I can be a part of the Iowa Core, if I can be a part of the water cycle, for instance, then I know I can get my education in. I'll have time for it. So here in Iowa, we have the FREE program, stands for Fabulous Resources for Energy Education. And yes, I used FREE because teachers remember the acronym FREE. We have a loan program with model solar car kits, Kiss the Wind kits, And these are just the pieces. The students themselves have to assemble these into the cars and the wind turbines. We also learn out some hydrogen fuel cells and many, many other pieces of equipment. We have graduate credit classes for educators. This semester I'm teaching a class, and I have 22 teachers in there. I have 11 industrial tech and 11 science and math teachers. We do outreach programs where we actually go out and do programs for schools and teachers. And we do public presentations. Here at the Iowa State Fair, we have an event there. We do other events as well. But what about some other resources if you're not in Iowa? Well, Green Learning in Canada is fantastic. I'm going to let Tim, I think, explain about that perhaps later. Just across the border, across the Mississippi in Wisconsin, they have a fabulous, fabulous program called K-12 Energy Education Program. It's the KEEP program, and they do pretty much the same thing, professional development. They have resources, and they have been doing that for quite a number of years. If you go to their website, they have an online course you can take so that you can get credit for learning about energy. Another great resource is NEED, NEED, National Energy Education Development, and they have all of their curriculum materials and activities available as PDFs, so you can download those and have those for free. I'm really interested also in green schools, in trying to help our schools to be more sustainable. And the resource that I use there is the Center for Green Schools. And so that's another great resource if you're interested in that. Here in Iowa, I don't know if you realized it, but we're second in the nation here in the USA with wind power. And so I love to teach about wind energy. And I have found that the Danish Wind Industry Association has a wonderful website. They have what they call their guided tour on wind energy. Each one of those topics includes a number of subtopics. They're written in simple, easy to understand language that teachers and students both can understand, and just covering every topic imaginable about wind. Now, over on the left-hand side under Know-How, you'll see another part of it. It's called Wind with Miller. Well, I really like Wind with Miller. And you can get him in all sorts of different languages. So if you don't want English, you can just click on another language there. And this is a highly interactive website. And Wind with Miller, he's just plain fun. Another good source for wind curriculum is KidWind, and their materials are now available for free. You can download PDFs. If you prefer to buy them, you can buy paper copies as well. But the PDFs are available on their site and free. I have a personal preference for my turbine kits over theirs, but their wind curriculum materials are outstanding. So I feel like I've talked long enough. Many, many thanks to all of you for joining me and letting me talk about my program with you. And right now, we ask, do you have any questions? So I'm going to unlock my...
Thanks, Pat, and thank you for moving that slide. And indeed, yes, we're now going to pass on questions to Pat. If you can take a moment and type them into the box and then hit the button Submit, please do. Meanwhile, what I'm also going to mention to you, because I know some of the detail on the slides was a bit small for us to see, but I want to point out that after sometime, probably by noon tomorrow, the archive of Pat's presentation, including the questions that we're going to discuss in the next 25 minutes, that archive will be available to you. We'll send out an email to everyone on this webinar, and to all those who were unable to join us but registered for it. We'll get the link to how that you can go, and you can share that link with others as well. But anyways, let me see if there's any questions that have already been asked, and I'll be right back.
While Tim is off looking for questions, I'll just say thank you for all the applause. That's wonderful. I feel great. And since I can read your comments here, how many of you actually did the experiment? Did some of you have those cups and see a difference in the warm and hot earth? I see that someone's warm bag produced more droplets. Sometimes that happens if you have your water a little too warm. I hope that was it. Sometimes I spill and my warm bag will have more flood water, but that's only because I spill. Another question.
Pat. Sure, Pat. I was going to say, Vanessa asks, do you have other sort of neat demonstrations that you do with students and teachers, student teachers, and all, just like the one you did with us tonight with the 2 styrofoam cups and the quart Ziploc bags?
Yes. One of the things I really like to have my students do is the Keeling carbon dioxide graph that we showed earlier. I like to have my students, I give them the data and I say, graph it for 2 years. And they graph that on an 8.5 by 11 sheet. And then we put all of those 50 years, that's 25 8.5 by 11 sheets. It covers the entire wall from floor to ceiling. I tell you, there is nothing that really hits you in the gut like that one of, wow, we've got a problem here because look at how that carbon dioxide is growing. And then we've got several others too. We're in the process of redoing our website. Our old website, I think I listed there, but hopefully those resources will be a little easier to find in our new website, which should be up shortly. But you can also find a lot of those activities on our website.
And thank you very much, Pat. And Stacy is asking, do you have other sort of experiential activities? This is a little more similar. Sounds similar to the last question, but it's a little more specific to climate. Do you have other experiential activities to share that reveal climate-related messages?
Well, in addition to that carbon dioxide graph, I do have, a lot of people tell me, well, climate change, it's just part of the natural process. It's just part of our ice age. So I do work with that Milankovitch cycle and try to show them that based on that, we really should be getting a lot colder right now, not warmer. And so there is kind of an activity that we do with that, but it's more of a paper and pencil thing. And again, I can make sure that that's on our website.
Pat, next question. Susan is asking, do you have summaries of other energy teaching modules that you use that you want to mention?
Unfortunately, we're not as good at writing things down as we should be, but we are starting to make YouTubes, videos of them. And so, again, we'll get those links up. But I find that a 5-minute YouTube can really show you what we're trying to do. It won't have all the details of a lesson plan, but I think teachers are more likely to watch a YouTube video than the other. I do get a lot of materials, of course, from online. The Need, the Keep. There's another great resource that's coming out of Vermont, and it's already in the 5e format. So But for myself, no, we've not been as good about writing things down as we should have been.
Okay, Pat, another question from Sandy is how do you translate this this type of activity into the kind of activities you've been talking about into an inquiry model? What are the kinds of leading questions and so forth that you would use?
Oh, that is a hard question. Those leading questions, I rely a lot on our science education department here at UNI. So, they have some kind of sample leading questions of how to kind of pick those little brains open and start to get them thinking about them. I guess, it was so hard to do it here today because it wasn't an inquiry model that we did. I'm not going to be able to pull off a bunch of those questions off the top of my head. I do apologize.
No apologies needed. Actually, I didn't quite lead the question. I didn't explain the question well enough that Sandy had. Let me just ask the supplementary part that she's asking, which is, can you give us examples of kids who ask questions and then take a lesson off in an unexpected direction?
Well, we do a hydrogen fuel cell example, and my engagement for that is I give the kids a glass of water. It's distilled water, and in the glass of water we've got a bunch of straws. And so the first thing I do is I ask the students, "Hey, would you like to taste some astronaut water?" And so they hold their finger over their straw so that they trap some water in there, and then that way they can get a little sip of distilled water. And it's kind of fun because one of the students, he was so excited that he was drinking astronaut water. I'm hoping he'll be a future astronaut. Anyway, he said to me, "Where do you buy astronaut water? Do you have to go to the NASA store?" So sometimes it's a question like that can really, you know that they're paying attention and you try to work on it from there. I also try to lead them into questions. For instance, we have the little model solar cars, and we use those. I ask a question, will it matter how you cover a solar cell? Because we know that depending on how you cover it, you can actually have the entire solar array not working depending on which solar cells are covered. So I start with that question, and then we actually go through and, cover it in a couple of different ways. And that allows me to lead into, well, then how does a solar cell actually work? And then we have a little worksheet where we go through and we learn about the free electrons and how they move. And, of course, solar cells are made out of silicon. They're made out of glass. So while the sun is shining, that's great. That means that your silicon, you've got a battery. But the minute there's no light on there, all you've got is glass. And so suddenly, instead of a battery, you have a giant resistor in your circuit. And because they've had a chance to first do the experiment and then we try to understand how the PV cell works, then I'm trying to coax that answer out of them. So that's the way I'm trying to do it.
Thanks, Pat. A couple more questions. One, Ariana is asking, what would you suggest, or are there other issues that you would raise other than climate change to get kids interested in energy and the importance of energy education?
Yeah. I'm not sure where she's from, but I'm from Iowa, and the western part of Iowa is so conservative. You can't really say too much about climate change out there because they're all convinced it's just a bunch of hooey. But the neat thing about energy, teaching about energy, is there are so many other advantages that you get out of that. The fact that and when I asked my teachers this question, what is probably the best approach for teaching about energy, they immediately said national security. I don't know. Americans are kind of paranoid about that. And so taking energy education from a national security perspective seems to work pretty good if you've got a really conservative base. You know, those guys, they're all about low taxes and high defense budgets. So if you can tie it into the fact that we're going to have our own homegrown energy, we won't need to import it from places. When we buy gas at the station, we're not just sending money over to buy bullets to be shot back at us. That seems to work pretty well.
Thanks, Pat. A question from Jeanette here in Toronto. Hi, Jeanette. Can you give us detailed information about the kits, what's in your kits, what's involved, or the costs? And I'm going to add to that, maybe even suggest that if you can provide us, anyways, let me let you answer the question.
Okay, I'm going to lock the talk because I've got to get my mouse over here, and I'm going to go up a little bit here. I think there was a picture. Okay, here. All right. Hopefully it's showing up for all of you now. The little car kits were the first thing that we developed. Some of you may have remembered the National Junior Solar Sprint Race that used to be held in Golden, Colorado. That was a kit that required a much larger PV cell. It was about the size of a shoebox lid, and it cost like $40 to $50. So when that program was replaced by a hydrogen fuel cell kit, there were no tears here in Iowa because we had already begun to put together this kit. Our little solar cell is $5 or less, and our kits we can sell them for $15. That's 15, not 50. It's $15. And we send those kits to the teacher depending on how many she needs. If she's got 30 in a classroom, we recommend 15. If it's a smaller group, like a talented and gifted group that's got 12 kids, we send them 12 kits. So the kids can put the cars together, and then we ask that they send back the cars already assembled because kids are not very careful when they're tearing their cars apart. So we ask them to just send the cars straight back to us, and there's no charge if they're in Iowa. But the neat thing is, for $15, if the kids want to keep their car, they fell in love with it, they can't part with it. Sometimes they just send back the money instead of the car, and it's all these little crumpled bills. It looks like lunch money. But the neat thing is that then they've got the motor and the PV panel, and I'm just really hopeful that they're really busy at home continuing to learn more about solar energy. The wind kits are also $15. We've just developed things ourselves here at UNI. I've got some very talented students. We just, back and forth, we keep trying to improve our kits. I have had some other states contact me. They say, I've seen your program on your website, and we love it, and we're writing a grant. And then they use our website to show what they want to do. And because I've got the prices there of the materials, they know what it's going to cost for them to set up their own state loan program. Because, boy, our schools in Iowa really can't afford materials like this, and our teachers really appreciate the loan form. That kind of got a little bit windy, but I hopefully.
Great, Pat. Long-winded answers are good answers, and that was a good one. Do you have suggestions of teaching children outdoors away from school settings? There's lots of people on this, probably in this group tonight, that don't teach in classrooms, but want to be able to teach climate literacy, energy education, energy literacy with kids out of doors and away from schools. Any suggestions for them?
I don't mean to be abusive, but we call those kinds of teachers the bird, bee, and tree group because, they love their birds, bees, and trees. And we love it that they're teaching our children about the birds, bees, and trees. But what I'm really, really concerned with is that with climate change and how it's affecting our birds, bees, and trees, I think it's absolutely critical that they make that connection for students so that energy efficiency, anything that can reduce the amount of energy that they use, is going to reduce the CO2, and that is going to help to preserve the wildlife that they love so much. So, I just really, really encourage them to do include energy education and energy efficiency as part of what they're teaching. We can build these little things outside, but I think energy efficiency and some energy efficiency games are real important at that time too.
Pat, Angela is asking, going back to climate change, and of course there's many states and provinces where it's not so controversial. But still, even where in those places, the big problem that educators have is, especially if you're dealing with younger children, is not to overwhelm young kids. And climate change can be a very overwhelming topic. Do you have any sort of suggestions for teaching kids about climate change without overwhelming them?
That reminds me of something that when I grew up, and you can see I've got gray hair anyway. When I grew up just a little bit east of here, and for those of you who don't know Iowa, I grew up with Rockwell Collins, which was a supplier to the defense for radios and all sorts of electronic equipment. And then just to the west of us was John Deere Tractor, and they could convert and make tanks and military equipment. So when I grew up in the 50s and early 60s, I can actually remember laying in bed wondering when I heard a plane go overhead, are they going to drop a bomb on us? Because, all I ever heard from the neighbors that were talking with my folks was how we would be one of the first places that they would hit because they'd want to take out those two targets, And so, I really identify really, really well with how scared children can be about climate change. But I think what we have to do for them is to give them a chance to do something about it. And that's where energy efficiency comes in. Those kids can really make a difference in their families about shutting off lights and reducing the amount of materials that they use. We have to warn them that they're going to be in a more dangerous world. But by giving them some control over it, I think that can help to reduce anxiety. I can tell you, as a kid, wondering if the plane was going to drop a bomb on me, there was absolutely nothing I could do about that. So hopefully, that's going to help them a little bit. But I'm not a psychologist. Maybe we can get some help on that from someone else as well.
Thanks, Pat. David is asking, I think you've answered the first part of his question, which is, how he lives in a very conservative community where people really are actively denying and resisting the connection between rising CO2 levels and the changing climate. But he was asking, are there websites that you would recommend where one can get the solid evidence about climate change? And that's one thing. And I think you've already answered the other question he was asking, which is, how would you respond? Because your earlier part of your presentation had that wonderful carbon cycle and water cycle that really, I think, was a really nice way to bring the topic forward. But are there websites that have the scientific evidence that show that the human impacts on climate?
Well, I'm from Iowa, so I rely on another Iowan, Jim Hansen from the Goddard facility. It's a NASA group out there in New York. He's the one that kind of risked himself and his job by talking about climate change even when his bosses would have preferred he was quiet about it. So I rely on NASA sites. The International Panel on Climate Change is another good one. But even then, I don't think even they understand the full picture, the full implications. I'm wondering, would this be a time to talk about natural disasters? Shall we go ahead and work that into the presentation at this point?
Go for it, Pat.
Okay, well, I was worried that we might not have a talkative group here, so I threw in a few extra slides. And this comes from the United Nations, who have been tracking natural disasters since 1900. And if you go to this website, you'll find all of the details about what is called a natural disaster and, how bad it has to be before they'll count it. But and some people will say, well, I'm sure that they weren't counting as well in 1900 as they were counting more recently. And I agree, that's probably true. But okay, so let's say you don't really want to see the first half of this data. Let's go to the details that are there. This shows the hydrometeorological disasters from 1970 to 2005. And as our hot water, warm water cups have shown us, flooding is going to be a real problem. It's just increasing all the time. The other thing that I said you couldn't see, but it's happening too, look at the windstorms. The thing that's a little harder to explain are the droughts and related disasters there. The best thing you can say is when there's, mega buckets of water in one spot, it means it's not available in another. But overall, we're seeing a lot more rain. And it's simple, you just saw it in your cups. When it's warmer, there's more evaporation, and that means more condensation. Here's another slide. And this one's showing the biological disasters. If you think of Haiti right now, just this morning on the news, they were talking about how they're still having trouble trying to control cholera, because after disasters, quite often your water supply is a problem. The other thing with global warming, we're seeing a spread in mosquito populations, and of course that's going to lead to more disease as well. So they're really expecting that to increase as well. But now here's the next slide, and remember I said I didn't think we were seeing the full picture. I'm just going to give you a chance to look at this for a little bit. Earthquakes and tsunamis have been on the rise. And I want you to be thinking about what causes an earthquake. How do we scientifically explain that? And you'll probably be thinking about continental drift and those plates that we have, oceanic plates and land-based plates. I like to use the example of New Zealand because I did have a chance to visit there. The east side of the island is fairly flat and lots of great agriculture there. On the west side, they have mountains, and they used to have a lot of glaciers, really big glaciers there. When I visited, it was quite a walk to get back up to the glacier because so much of it had melted away. And as anybody who's from a cold area knows, when you shovel snow and have to push around ice, it's heavy. When we lose that weight, all of that weight from those glaciers melts away. And, of course, in Greenland as well, we're losing weight there. I'm an old physicist. We're changing centers of gravity here. We're adding more weight to the oceanic plates. We're taking weight off from certain areas of land-based plates. I just in my mind can visualize those plates shifting, and I really look forward to seeing more data on this. I really want to see more scientific explanation on this. But up to this point, the International Panel on Climate Change has not even mentioned earthquakes as being related to climate change. I have a suspicion it is. As I said, if I were a scientist, a young scientist, I think this is where I would be looking right now. So there's my little part for that.
Thank you, Pat, and I'm really glad we got into that detour. I have a great interest in climate change education myself, and I was particularly fascinated by those last three slides. So that was what I guess I'd call that a bonus. We got a bonus answer at that point. Pat, if you could now, I think what I would recommend we do is to advance to the next slide or go back to our evaluation slides. And I'm going to ask everybody on the call to do two things. The first one is there's actually several questions here. We'll give you a chance to answer the first one, and then we'll move the slide up a little bit. But it'll take maybe a minute or 2 minutes to respond to these questions. But I was going to also suggest we don't have a huge crowd tonight. It's a good time. Once we finish, those of you who can stay for a few minutes, I'm going to ask Bridgepole in a couple of minutes to unmute everyone, and we'll give you a chance to speak. We'll explain how to do that in a minute. But at the moment, so do consider sticking around, and you get a chance to ask in your own voice, Pat, any other questions you have. Pat, can you just draw down this slide a little bit lower so that we can raise the third question?
Tim, everyone can individually raise the slides down.
Thanks, Bridge.
Well, yeah, and I think that we're all set to go here. Great.
So we'll just hold this for another 30 seconds in case you have any questions or you need to type a little longer into any of the boxes on this slide. And I've also been pleased to see we've had a pretty active chat going in the chat room and some good comments there. People talking about, and I see Rob has just nominated or recommended The Operator's Manual is a new book from climate scientist Richard Alley. That looks great. And so do stick around, folks, if you like. In just a moment, we will now, Bridge, can you now, I think we'll leave the archive on. And Bridge, do you want to unmute the participants?
Yes, I will. And we want to leave the archives on, right?
Yes. Okay, so Bridge, I think you'll need to remind me how people have to, if you look at the gray bar in the bottom right-hand corner of your screen, it says, it lists all of our names. It says people, there's 23 on the call at the moment. And I think if you go to the happy symbol, or rather even to the symbol right in the very middle, just to the right of that. That's right. You've got it. Thanks, Rob. You can actually press that down, and I'm going to stop talking right now. So if anyone wants to press that button right afterwards and ask a question of Pat, please do.
You too.
This is Pat, and I just typed in a recommendation. Teaching about climate change or anything that involves people changing their habits, I found the book Switch, How to Change Things When Change is Hard, and it was written by Chip and Dan Heath. It's a couple of brothers. I found that very, very helpful, and I highly recommend that book. It's an easy-to-read book, not too technical, and just I think you're going to find that very helpful.
Does anyone else have a question of Pat? Pat, can you see Tammy's question in the chat box?
Yeah, I sure do. Second and third graders at school, their focus is on energy conservation. Oh boy, that would be the group where I would really hit them with energy efficiency. We've got a game, and again, it should be able to find it on our website. It's called the Light Up Your Life game. It really is a good game to show them how much energy and money they'll save using compact fluorescent bulbs. But I'd say energy efficiency games and having them count the bulbs in their homes would be a great thing for them to do.
And I'm going to add to that, Pat. We published, as you know, a few years ago, a book called Teaching About Climate Change, and one of my favorite activities for grades 2 and 3 was a teacher who actually teaches up in Fort McMurray, where all that really dirty Canadian oil is now coming from. I just a little dig about us being reliable Canadian sources of oil for you guys south of the border. But up there in the where it gets very, there's only a couple hours of light in the darkest days of winter. She wrote a wonderful article for us about how she introduces energy to really young kids. And what she does is she has kids grind up nuts. And obviously she makes sure that there aren't kids in the class who have nut allergies. But she grinds up nuts with a rolling pin, has the kids do it rather. And then she gets out the blender or the food processor and has them make a nut butter using electricity. That's just one example of many that she uses in her article. But it helps she has the kids then compare the two processes and what are the advantages and disadvantages of making a nut butter by hand and then using a machine to do it. There's really many ways we can get kids thinking about energy right from very early ages, and that's just another example.
I see they're asking me to repeat the reference. I believe if they go to the chat box and push that little button up, they'll be able to see, but I will repeat it here. Switch, How to Change Things When Change is Hard, written by Chip and Dan Heath, Heath. I see Jenny asks ever taught primary. I'm not sure if that question was for me or not. I was actually trained as a high school physics and math teacher, but as you said in the introduction, I had to teach. I was a teacher for a science center where I taught everybody, preschool through adults, and boy, you sure learn fast then that you got to be interesting or they walk away.
Okay, well, I think I'm going to take this opportunity to heartily thank Pat for a fabulous presentation tonight. I learned a lot, and I've been involved in energy education for a long time, so I'm just really enthused about what I've learned tonight, Pat, and so I want to thank you very, very much for taking the time to not only put together a great presentation, but also your wonderful answers to the many questions tonight. So I really appreciate this. And I'm going to, if you have any suggestions, Pat, or other resources you think of when you, after this webinar that we'll be sending out, I'm happy to include any messages from you in the follow-up email we'll send out about noon tomorrow. So if you can send them by 11 o'clock your time, that would be great. And we will send to all of you who are still on this call an email that indicates where the archive is. Feel free to share that with your friends, and do look forward. We're going to be posting a whole bunch more webinars this weekend and early next week. So it'll start in a couple of weeks. So please do consider signing up for another one. These have been really fun. It's been a whole new learning experience for us here at Green Teacher, and we're looking forward to finding ways to do many more of them in the future. So thank you very much, and good night, everybody.
Yes, thank you for having me. Good night, all.
Now, Pat, while you're still here, now I have to give you advance warning. There's several good things that you've shared with us in this presentation. Especially, I love the plastic bag and water vapor activity. And I think I just want to say, as the editor of Green Teacher, just to give you a forewarning, that I think you're about halfway through putting together that article yet to be finished for Green Teacher magazine.
Yeah, as I said before, writing things down is not my strong point, but I do need to do that more often. And so, yeah, maybe between you and me, and we'll get something written up yet.
Sounds great. Again, I'm gonna tune off tonight. I'm gonna sign off right now. I've got a cat who's wondering why his food bowl is empty downstairs, so I'm gonna go take care of him. So I'll say good night to everybody, and we'll look forward to next time. Take care.
Tim, before you leave to feed your cat, I'm going to be out of town tomorrow, so I'll just send you a quick note right now.
Thanks, Pat. That's perfect, and safe travels.
Thanks, Pat, for a wonderful presentation. Thank you.
You're welcome, Bridge. How's your little one?
She's doing well. Thank you.
And thank you too, Bridge, for doing such a great job in the backdrop and getting this all set up. We wouldn't have been able to do this without you. And I think this is actually our first, by the way, we didn't actually celebrate this, but this is our first problem-free presentation. And I think we finally got some routines. We've learned things the hard way, but it was really great to have this go without a hitch tonight. I hope I haven't missed any of the hitches. I know a few people had trouble logging on, but otherwise it went pretty well.
I am very pleased that it went
You're right.
as well.
This is the first one. Yes, it went perfect. Great. Thanks, Tim. Thanks for.
Good night, everybody. Take care.
Good night, all.